Hello students, welcome to chapter 13 Limits and Derivatives. In students, today we going in the derivative for the formula related our ninth one using working rule. Find the derivative of given x raised to 5, 3 minus 6 x raised to minus 9 in exercise 13.3 question number 9. Students, first I multiply here in this internal form. And simple we getting one of the product form d dx of 3 into x raised to 5 and same as x raised to 5 with x raised to minus 9. Now students, here base same, power additions. So you get just 3 into x raised to 5, but that is 5 minus 9, it is minus 4, and apply the working rule. 3 into x raised to 5 same as 6 into x raised to minus 4, and simple apply your formula x raised to n is equal to n x raised to n minus 1. So 3 into 5 x raised to 5 minus 1 same as here minus 4 x raised to minus 4 minus 1, indirectly that is r the 15 and x raised to 4. Here 6 4s are 24 but x raised to minus 5. So my answer is just 24 by x raised to 5, and that's your answer. Now continue question 10. Sorry, not question 10, 9th. Continue your 5th one. Yes, question 9, 5th one is also same as in the product apply d dx of x raised to minus 4 into 3 minus 4 x raised to minus 5. Just here also I will multiply and we derive into one of the polynomial form that and this. So d dx of 3 into x raised to minus 4 and second minus 4 into minus 5. So does here base same whenever you power additions means minus 4 minus 5, it will be minus 9. So d dx of 3 into x raised to minus 4 and second d dx of 4 with the x raised to minus 9. Now formula you know, so here 3 same is, and here I will apply n a raised to n minus 1 minus 4 x raised to minus 4 minus 1 same as here minus 9 with minus 1. So totally you getting minus 12 x raised to minus 5. Same 9 4s are 36 x raised to minus 9 and one of the minus 1 means minus 10. So finally you will arrange x raised to 5 plus 36 x raised to 10, and that's your simple and easy answer. Now continue students in the way of continue 6th one. 6 is IMP for related final exam. Very easy, but a big one. d dx of, there is a two partitions, one of the second 2 divided by x plus 1 minus and second given x square upon 3x minus 1. One more time check, 2 divided by x plus 1 minus x square upon our 3x minus 1. Students, here two parts, one of the first, one of the second, I will take both separate and using the working rule our division forms. So first of all d dx of 2 upon x plus 1 and second same x square upon 3x minus 1, and start the simple our formula to division rule in denominator square. Now denominator d dx of numerator minus numerator d dx of denominator. That's your simple division rule. Similarly students, minus here apply again division rule to same concept. Yes, in denominator square 3x minus 1 square, but here 3x minus 1 d dx of x square. minus now x square ddx of 3x minus 1. Now simple apply both of the formula. So my first answer is here x plus 1. This derivative constant, so 0. Here x derivative respect to x1, so 1 derivative 0, and upon x plus 1 whole square same is minus. Here minus, that's why I'll take in the brackets, and calculation is a 3x minus 1. So it is your x square derivative, you will take x raised to n, I mean 2x minus x square. Here derivative 3, x derivative 1, and constant there 0 upon 3x minus 1 whole square. Now answer to take you individually, one of the here 0 minus 2 upon x plus 1 whole square. Here this multiply, so minus the total 6x square minus 2x minus 3x square, and upon as usual. Finally you will arrange your terms and you will get lastly answer. So actually both parts are separately I calculate by the division working rule. So my answer is minus 2 below x plus 1 whole square, and here students finally 6x square minus 3x square, 3x square minus 2x upon 3x minus 1 whole square. Indirectly this numerical done, but in textbook answer here just common taking, so minus 2 by x plus 1 whole square, only x common, so 3x minus 2, and that is same as 3x minus 1 whole square. That's your finally answer for this question number 6. Now students continue, we going ahead. Question number 10. If for fx given cos x, find its derivative by the rule of first principle. Yes, by the first principle. First principle means students definitions, and cos x derivative already known that minus sin x. Yes, here asking first principle, so I will start f of x plus h, which is cos of x plus h, and by first principle f dash x is equal to limit h tends to 0 f of x plus h minus fx upon h, and all value you will apply that one by one. So your value is the limit h tends to 0, it should be cos of x plus h minus cos x by h, and just revise the formula c minus c, which is minus 2ss, and operate that values. So I just using here my principle of the our trigonometry, cos minus cos minus 2ss, so limit h tends to 0 minus 2 sine of the sine, and divided by h is as it is. You know that both angle here divided by 2, one of the addition x plus h plus x and x plus h minus x. So finally here x and this x is cancel. Remaining I have limit h tends to 0 minus 2 sine 2x plus h by 2. Remaining here sine h by 2, and upon h is same as. So it is actually these two I will take the divide with h and arrangement by this sine h by 2. Indirectly sine h by 2 upon h by 2, definitely it is 1, minus common carry outside, so limit h by 2 tends to 0 sine h by 2 upon h by 2 same as, and other as usual I will show that sine 2x plus h by 2 by the working rule. This is a permanently 1, and here putting the limits, so minus 1 into 1, and that becomes sine 2x plus 0 by 2. So your answer is minus 1 into 1 into sin x. So d dx of cos x, this derivative, cos x derivative is conformly that which is minus sin x, and that's my answer by the first principle. Now question 11 directly asking the derivative using our working rule. Only 4 working rules are there, students, and that related asking one by one questions. Sin x, cos x. Question 11. First one, d dx of sin x into cos x. Just I will apply u and v, simple product rule. So first, second derivative plus now second, first derivative. I will show that product rule. And now both formula you know, sin x, cos x derivative is a minus sin x. Same as sin x derivative is also cos x. Finally minus sin square x here, and it is cos square x here. You will take values for cos square x first, minus sin square x second, and that answer is done. But this formula also you know, cos 2x. So my numerical is done here. Finally cos 2x, and that's easily and happily done. Continue in the second one. Only using the working rule asking the question, students. If you are asking properly by the principle, then go to principle rule. Second, sec x, d dx of only sec x. So sec x derivative you find out. Before that you will go the conversion of 1 by cos. It is reciprocal on it, and now apply division rule. So my division rule is in the denominator square, denominator d dx of numerator minus numerator d dx of denominator, and my answer is done. Here cos x, one derivative, 0 constant, and here cos derivative is minus sin x, and that is same as, that is conformly 0, plus sin x by cos square x. Students, I will do here one of the sin x into 1, and the cos square x we will write down cos x into cos x, because that I know, this also I know. It is a tan x into sec x. Is my answer is a sec x into tan x. That's your derivative of sec x, and that's my answer. So always you can by heart the formula sec x is a what? Sec x into tan x. Now third question. It's also very easy. Third one, d dx of, there are two data given, one of the 5 sec 4 cos, 5 sec x plus 4 cos x. One more time check, 5 sec x plus 4 cos x. So does here just we do by working rule 5 sec x separate and 4 cos x separate. Now both formula operate. Sec x derivative, yes, here I will prove sec x into tan x. So 5 as it is sec x into tan x, and cos derivative also you know that, yes, which is minus sin x. So your numerical done, 5 sec x into tan x minus 4 sin x, and that's your simple answer. Now continue fourth one, d dx of, our question is there, yes, it is a cosec x. Same explanation according to that I explanation cos, reciprocal of that sec, same as here cosec x. I translate in the form of 1 by, it is sin x, I mean reciprocal. Now go to division form, u by v rule, yes, in denominator square, sin square x. Now denominator d dx of numerator. minus numerator ddx of denominator. Just u by v rule apply. So sin x same, x1 derivative constant respect to x is 0 and minus here sin derivative which is cos x, and denominator is same as. Now here students, you will just separate it. This is a conformly 0. You have to only minus cos x by sin x into sin x. Actually I want to sin square x in the 2 form, here into 1. Definitely that you know and also that you know, and you will collect the answer. So minus cot x, 1 by sin is a cosec x. So your derivative answer is a minus cosec x into cot x. That given the answer in the next side, and here your over sum. Now continue students. After that fourth, we going ahead in the fifth one. Fifth also same, d dx of the two functions are given, 3 cot plus 5 cos x. Yes, 3 cot x plus 5 cosec x. Again I check, 3 cot x plus 5 cosec x. Both formula you know students very well. Just apply the working rule, d dx of 3 cot x and here 5 cosec x, and apply the answer for only cot x derivative. Yes, which should be minus cosec square x. And next same is here cosec x derivative. Previously I explained that, which is minus cosec x into cot x over numerical, but I will take the common minus cosec x. Remaining I have 3 cosec x and minus common, so here plus 5 cot x. Actually minus cosec x common taking, and remaining are 3 cosec x plus 5 cot x. Here done. Now students continue question number 6th one. Yes, 6 also same pattern, d dx of, the question is 5 sin minus 6 cos x plus 7. 5 sin minus 6 cos x plus 7. Only taking working rule to first data, second data and third data. So your answer is d dx of 5 sin x same, d dx of 6 cos x same, d dx of 7, and my answer is a 5 sin derivative is a cos x. Now cos derivative is a minus sin x, and constant derivative definitely 0. So your answer is 5 cos x 6 sin x. That's your finally answer, and easily get that the parts of this answer. Now continue question number 7. That also similarly going, and 7 is the last sum for this exercise. 210 minus 7 sec x. Yes, question number 7, d dx of 210 x minus 7 sec x. Just checking the questions, 210 x minus 7 sec x. Both apply working rule to subtractions. d dx of 210 x same minus d dx of 7 sec x, and both answer you very well known tan x derivative which is sec square x, and sec x derivative is a sec x into tan x. Now just you common taking, your remaining answer is only sec x common, remaining is a 2 sec x minus 7 and tan x. That should be your sec x common, 2 sec x minus 7 tan x, my final answer. Students, here exercise done. Now I go to miscellaneous example number 22. Yes, example number 22. There are two questions. First of all, d dx given the function solved by the first principle, yes, 2x plus 3 upon your value is a x minus 2. Again I repeat, solve the derivative of 2x plus 3 by x minus 2 by the first principle. So students, question is there, find derivative by the first principle. Please go to definitions. F of x plus h, we will derive that 2 with x plus h plus 3 upon here also x plus h minus 2. And now I will start the function formula f dash x limit h tends to 0 f of x plus h minus fx by h, and all values you put down one by one. So limit h tends to 0, that value is 2 times x plus h plus 3 upon x plus h minus 2 minus fx is the same as 2x plus 3 by x minus 2, and whole divided by h is as it is. And now you take simple LCM in this form and just simplify till up to removing h in the denominator. Yes students, this h I just removing that. So limit h tends to 0. Here apply the product rule, 2x plus 2h plus 3 with the x minus 2 minus here also same x plus h minus 2 into 2x plus 3 upon as it is 2x plus h minus 2 with x minus 2 and with h as it is. Only I take cross multiply with this LCM. Now both expanded, this expand same as this expand. So limit h tends to 0. You will take expansion by that 2x square minus 4x plus 2hx minus 4h plus 3x minus 6 minus now this chance 2x square plus 3x 2hx plus 3h minus 4x minus 6 and upon as usual form x plus h minus 2 x minus 2 with h. Now expand it totally, this minus multiply inside and you will get one of the unique form. Limit h tends to 0. Here expansion same as 2x square. All function are same, write down I minus 4h 3x minus 6 and here minus 2x square minus 3x minus 2hx minus 3h plus 4x plus 6 and upon as it is. This also same. Now you will just check this cancel. Also 4x with 4x cancel, 3x cancel, 2hx cancel, even 6x also cancel. You have to only this and that remaining. So my remaining data limit h tends to 0 which is minus 7h, yes, upon x plus h minus 2 x minus 2 with h. Now students, h and h cancel. That's the main point to removing h. Now putting your limits, your limit putting minus 7, h plays 0, write down. Here also x minus 2. So your total answer is minus 7 by x minus 2 square. That is the derivative of this function by utilization of our first principle. Now same 22 but the second questions is that 22 continue in the second one. Fx given x plus 1 by x. This numerical also IMP level, in the board level x plus 1 by x. I will start that same as using your first principle. So f of x plus h, which is x plus h, plus 1 by x plus h, and apply by definition of derivative either by the first principle f dash x, limit h tends to 0, f of x plus h minus fx by h, and apply successfully both values. So limit h tends to 0, it should be 1 by this value, I just put it, x plus h, 1 by x plus h. Fx is that minus x minus 1 by x upon as it is. So does this cancel x and x? Other, as usual, we will show that x, h plus 1 by x plus h minus 1 by x and upon h is same as. Here students, you will take maximum LCM. So limit h tends to 0. Here this is a product with h. So h into x plus h. Continue, plus x minus x plus h, and upon as it is h, x plus h, x. Again I repeat, this two product with h, here only x remaining, so x I write down, and here x plus h remaining. Now expand it until up to you removing value of h, then you get answer students. I want to anyhow this h is removed, so limit h tends to 0. Here hx into x, so hx square plus h square x, h and h cancel, I mean product it, and x, h square x plus x minus x minus h, and upon same is. Now students, this cancel. Another, you have to remaining parts, I will take h common, so limit h tends to 0, hx square, h square x minus h upon same is, and you will take just common h and remaining as it is. Here x square plus hx minus 1, and other also same, that cancel. This is the main point. Yes, h removed for denominator. Now putting the limits in place of h is 0. So you have to answer x square 0 into x minus 1 and x plus 0 into x. So x square minus 1 by x square, you will just write down x square by x square, 1 by x square, this cancel, and your answer is 1 minus 1 by x square. That's the students' final answer for this derivative of our 22 questions by the first principle, and the first and second question both IMP questions students, happily done here. Yes students, after that ending 22 examples, I will stop this video, and further explanations to continue next example I will explain in the next parts. Bye bye.